Hey guys, and welcome to this video on the C programming language. So in this video we're going to do some bitwise operations. So let's go ahead and get started. First thing I'm going to do is create a description for our program. So this program performs a few bitwise operations. Alright, now the operations that it performs are the bitwise and that is represented by this symbol here. Then we have the bitwise OR, and that's represented by this symbol, the pipe. And then we have the bitwise XOR, or exclusive OR, and it's represented by this caret symbol here. All right, so now let's go ahead and create our library. So we're going to include stdio.h, and let's create our main function. And I'm going to return 0 here. All right, so now we're going to create our variables to do the bitwise operations on. All right, and they're going to all be integers. So first I do x and I set it equal to 13. Then we'll do y and set it equal to 27. And then the last variable will be z, and I set it equal to 10. All right, and then what we're going to want to do is print out the operations. So I'm going to say XOR xy is equal to %d, and then we're going to do a new line, and we want to print out that value, and I'm going to explain why the values are what they are. All right, next we want to do maybe the and, so that's we could do x and z, and this will be equal to %d. We're going to do a new line, and then we have to make sure we tell it we want the bitwise and z. All right, and then last but not least, we're going to do the bitwise OR, and I'm going to use y and z this time. So y or z. Maybe I put it together like that. Okay, and then we want to print out that value, do a new line, and we said y or z. Okay, so I'm gonna go ahead and run the program just to see what values we get here. All right, and you can see that we get completely different values from what our x, y, and z values are. Let's see, y or z, it gives us the value 27. So that one's actually the same. So let's try to understand how the computer came up with these values and be able to do it ourselves. So one thing to note here is that 13 in binary is equal to 1101. Okay, so I'm going to say 13 equals 1101 in binary. 27 equals 11011 in binary. And the number 10 in binary is 1010. Okay, so I'm going to put a few spaces here for our print statement explaining why the values are what they are. Okay, so first up we have the exclusive OR. I'll put it in the comments here. So the exclusive OR, aka XOR, So we're doing X exclusive or Y. So X is equal to 13, which is equal to 1101, and our Y value is equal to 27, which is equal to 11011. So the operation that we're using again is XOR. So I'm just gonna put our operation here, XOR, and then move this over. Okay, and we actually need to move this over to match the bits here. All right, so what does this equal? So exclusive OR means that they have to be two different bits. So what we get here, one exclusive OR 1, which is here and here, that's going to give us the value 0. Okay, and then 0 exclusive OR 1 is going to give us the value 1. 1 exclusive OR 0 gives us the value 1. And 1 exclusive OR 1 gives us 0. And then you may say, wait, there's nothing here. Well, there's an implicit 0 here. So we get 0 exclusive OR 1, and that is just 1. Okay, so this is the binary digit we get back. And so what is this in decimal form? Well, let's see. So we have our zeros place, our ones place, our twos place, our threes, and our fours. So what we get is 2 to the power of 4, and then we get plus 2 to the power of 2 plus 2 to the power of 1. All right, so this would be equal to, let's see, 16 plus 4 plus 2. So this equals 22. And let's run the program and see if that's what we got here. Okay, so for the exclusive OR, we got 22. Okay, so now let's do something similar for the AND operation. Bitwise AND. So we're doing X and Z this time. So X again equals 13, which equals 1101 in binary. And then we have Z, which equals 10 in binary, that is 1010. And the operation that we're going to be using is the AND operation. All right, so let's see what binary digits we get from this. So for the AND operation, if we have a 1 and a 0, then we get a 0. If we have a 1 and a 1, we get a 1. And if we have a 0 and a 0, we get 0. So here we have 1. Oh, here we have 1, and here we have 0. So that just gives us 0. Then we have 0 and 1. So that gives us 0, 0 as well. Then we have 1 and 0. So that's another 0. And then we have 1 and 1. So that gives us 1. So what is this in decimal form? This is actually just 2 to the power of 3, which is equal to 8. All right, and let's run the program again, and let's see if we get that, or if we got that, which we did. So for the AND operation, we got the value 8 back. And last but not least is the OR, the bitwise OR. So bitwise OR, we are using y, and y equals 27, which is equal to 11011 in binary, and then we're using z, and z is equal to 10, which is equal to 1010 in binary, and we're going to be using the OR operation. All right. Okay, so let's see what we get back here. So 1 or 0 will equal 1. 1 or 1 gives us 1. 0 or 0 gives us 0. Again, 1 or 1 gives us 1. And we have 1 or an implicit 0 here. Okay, so that's 1 or 0. And again, that's just 1. Okay, so this is the binary number that we get back. And this in decimal form is equal to, let's see, we have the zeros placed, 1, 2, 3, 4. So we get 2 to the power of 4 plus 2 to the power of 3 plus 2 to the power of 1 plus 2 to the power of 0. And this is equal to 16 plus 8 plus 2 plus 1. And this gives us 24, 26, look like 27. So the number that we should get back is 27. And I'm going to run this again, and we get back 27. So thank you guys. I hope that explains these, at least a few of the bitwise operations in the C programming language. Please leave any questions you have, any comments. Don't forget to share if this video was useful to you. Maybe it could be useful to someone else. Don't forget to subscribe, guys. And as always, thanks for watching, and I'll see you all in the next video. And I will be sure to have this program on my GitHub in the description below, so you can download it yourself. So again, thanks for watching, guys, and I'll see you all later.